Hey everybody, welcome to our conversation today on units and conversions, okay? So this is the beginning of our measurement unit, which is only a short 3-day unit where we're gonna talk a little bit about the different units that are appropriate to use in chemistry and how we convert between them, as well as how do we appropriately measure. Okay, so let's dive right in. So I was actually lucky enough back in 2019 over the summer, last summer, to visit France for my honeymoon. And before I left, I got into an argument with my colleagues about which building is more impressive. Now, I argued that the Empire State Building in our beloved New York City was the more impressive building. And my colleague, Mr. Mulick, who'd already been to Paris, said, no way, the Eiffel Tower is much more impressive. So that got us thinking, let's do some research. And Mr. Mulick and I both looked up different information about the Empire State Building and the Eiffel Tower. So I found that the Empire State Building is 443 meters tall. And Mr. Mulick discovered that the Eiffel Tower is 1,063 feet tall. Now, this led us to a problem. Our units don't match. So how can I compare the Empire State Building to the Eiffel Tower if I don't have matching units? And unfortunately, this is a problem that happens all too often because countries from all over the world use different units. Now, when I say that, I mean primarily the US uses very different units than most other countries, but that's why it's really important for us here to kind of understand what we call the standard units, which we'll talk about in just a moment, because they are going to be how we will communicate with every other country scientifically. So what we're going to look at today is not only which building is more impressive, because we are going to discover that by the end, but we're going to also look at how do we convert units, right? How do we convert units? Now, this leads me into what are some examples of units? Now, you guys are probably very familiar with different types of units, either from science or just from measuring things at home. And obviously, I can't hear or see what you guys are suggesting to me since this is pre-recorded, but I do have the answers my kids from last year gave. So what I want to do first is go through what are some of the ways that we measure mass, okay? And my students from last year suggested we measure mass in grams, we measure mass in pounds, we measure mass in ounces, we measure mass in kilograms, okay? Ooh. So we're going to measure that mass in kilograms, if I can get this to right. Okay, maybe not, but that's all right. I'm going to do it over here, so kilograms. Okay, we can measure mass in tons. Okay, what about how do we measure length? Okay, so how do we measure length? So we measure length in feet, according to my students last year. We measure it in inches. We measure it in centimeters. We measure it in meters. Okay, and we measure it in miles. Okay, and what are some of the ways that we're going to measure volume? Okay, so some of the ways that we measure volume, we measure it in liters. We measure it in milliliters. Okay, we are going to measure it in gallons or in cups. Or what else did they suggest? They suggested quarts. Okay, so we have lots of different ways that we can measure, which again, like I said, leads us to this point of we need a standard way to measure so that we can communicate from country to country. So from the US to Russia to Spain to China, we all need to use the same units. And so that leads us to what's called the Standard International Unit, or the SI unit, or I believe it actually stands for System International. Okay, so our SI unit, okay, is going to be our standard international units. So what is widely accepted throughout the world as to how we're going to measure? So let's go back to our units list and come up with our SI units. So our SI units, or our SI unit for mass, is grams. Okay, our SI unit for length is going to be meters. And our SI length for, or our SI measurement for volume is going to be liters. Okay, now looking at these lists, you might also notice that we have some variations of grams, liters, and meters, right? So looking at just the mass, notice that we not only listed grams as an option, but we also listed kilograms. So a kilogram is going to be an extension of the gram. The kilogram is essentially telling us that we have so many grams that we need to measure it in a larger amount, or a kilogram. Okay, looking at length, we have meters, but we also listed centimeters. Okay, and so again, meters is our SI unit and what we're going to call a basic unit, and centi is an extension of that basic unit. Next, looking at volume, we have liters, and then we also listed milliliters. So again, that's going to be our extension on our base unit. So let's go ahead and define our basic unit then. So what is a basic unit? Well, a basic unit, okay, is going to be the unit of which our extension units are based off of. Okay, so that's kind of a redundant or like really kind of ridiculous way to define it, but I'll show you what I mean on reference table C. So you actually don't need to memorize all of these prefixes that come with these basic units, because on your reference table on the very front side, there's what we call reference table C, or our selected prefixes. So let's take a look. So we list kilo, deci, centi, milli, micro, nano, and pico. Primarily going to be using the kilo, centi, milli for this course, though we may at some point see some things that are listed in nano or pico. Okay, but let's take a look at what this means. So we're given a factor, okay, and that factor tells us how many of our basic unit is in our prefixed unit. So what this means when I see 10 to the third is it means that I have 1 times 10 to the third, or if we convert that, 1,000 of our basic unit for every 1 kilo unit. Okay, so this could be 1,000 meters for every 1 kilometer, or 1,000 kilograms for every 1 gram, or 1,000 grams for every 1 kilogram. Okay, so you can insert any basic unit and put that prefix right on top of that. What about when they get smaller? What does that mean? Okay, this means, let's use centi for example. Okay, we have 1 times 10 to the negative 2, okay, of our basic unit, okay, which is also the same thing as saying 0.01, okay, equals 1 centi unit. If that's confusing for you, you can also think of it as, flip this and say I have 100 centi units, okay, for every 1 basic unit. Okay, so that's our table C. Now, before we talk about converting between different basic and prefix units, okay, or extension units, I do want to kind of use an example just to go through what we are going to call dimensional analysis, okay? And that's a very scary sounding word, but it's not so scary, I promise. So here's a problem that will help us relate this back to something that we all enjoy, which is food, okay? So let's hypothetically say that I needed to make 800 breakfast sandwiches for the freshman class, okay, which sounds insane and I would never be able to do it. Okay, so let's say I had to make 800 breakfast sandwiches, and each breakfast sandwich, okay, required 2 eggs. So I need to know how many dozens of eggs I need to go to the grocery store to purchase. Now, you might be saying to me, well, this is a really easy problem, right? Very easy to solve mathematically. I have 800 kids. Each kid is going to require 2 eggs. Okay, that's going to mean I need 1,600 eggs. And each dozen has 12 eggs. And therefore, I would require 133.3 repeating dozen, which again, of course, would round to 134 because we can't buy 1/3 of dozens. So that mathematically was very easy to solve. But what you didn't know is that within this problem, you were actually using different things like dimensional analysis without even knowing it, and what's called a conversion factor. So a conversion factor, okay, is going to be a piece of information which relates to units, okay? So a conversion factor relates to units. So which conversion factor did we use in that previous problem? Well, we used the idea that 1 dozen is equal to 12 eggs. This is an example of a conversion factor, okay? We are taking a unit, dozen, and relating it to a secondary unit, eggs, and we give them numerical values 1 and 12, okay? So this is also kind of like what we just learned about with those prefixes and those basic units, right? 1 kilogram is equal to 1,000 grams. This is another example of a conversion factor. So what then, you may ask, is dimensional analysis? Well, dimensional analysis sounds super scary, but it's not actually scary because it's actually in the long run going to be super, super helpful for us all. Okay, so dimensional analysis is a mathematical process, okay, a math process to help us track units. Okay, and what's really cool about it is that we actually, when we're keeping track of the units, it sets the math up for us. Awesome. So what do I mean by that? Let me show you what I mean. Okay, so let's say again we were looking at that same problem with the kids, the eggs, et cetera, et cetera, et cetera. Okay, and let's say that we were actually, let's not do that one. Let's do the one where there's how many seconds there are in 5 years time. I'm going to exclude leap years. Okay, so we start off our math and we say, okay, we have 5 years. Okay, well, we're not going to go straight from years to seconds because I don't know how many seconds there are in a year, but I do know something like how many days there are in a year, right? So when we're doing dimensional analysis, we want to set it up. This is our conversion factor, right? That goes into here. And we know that for every 1 year, we have 365 days. Now, we want the years to cancel, and we want to end up with days as our unit. So how do we set this up? We're going to set this up by saying for every 1 year, we have 365 days, okay? This allows us to cancel our years unit and end up with days as our unit. Now, continuing forward, what other conversion factor do we need? Well, we know that for every 1 day, I have 24 hours, okay? So here we go. We want to cancel days. So we have 1 day, 24 hours, okay? What else do we need to know? We know that we have for every 1 hour, 3,600 seconds. So let's go ahead and set that up. For every 1 hour, I have 3,600 seconds. And so what does this look like? Our days cancel, our hours cancel, and our seconds are left. We already set up the math for us because if everything is in the numerator, all that means is that we multiply these through, and this is going to give us how many seconds of time, okay? This is going to give us a lot of seconds of time. Why don't you come to class with that answer, and we'll go over the rest together. Have a great day, guys.